So you develop this enormous canon with people highly specialized in different directions.
Yeah.
And the problem is associating the information from all these different areas into one big
I think
picture.
it is. And I think that's when you say you study quantum gravity, it should be that. Instead of fighting over, whose approach is going to be the best or whatnot. But yeah.
So is it, in some sense, a data science problem, or?
I would say that there is a data science problem or engineering challenge associated to our field. And the thing is that a place like Perimeter is probably the only place that's in a position to try to tackle that, or at least say that that's a goal. And so I really actually am happy that I'm employed here.
But because it has the resources.
It has, at least nominally, it could have the resources if it dedicated to it. And I think that the awesome thing about being faculty here is that you do whatever you want. I mean, it's super fun. But it's just because I don't think there's any other institute with the level of funding, for example, that's dedicated to theoretical physics. So the way that academia tends to work is you have these Ivy League schools that try to get the top talent. They can get whatever top talent they want in any field. And so whatever string theory group or high energy theory or any generalization thereof, they can get some researchers, they have them, their research portfolio is the only thing that matters. They don't care about your subfield. They're basically hedging their bets by having a diverse portfolio of research programs. And if they can get the top person, that's great. So even at Harvard, which has a really, really strong string group, it's not like they're the priority of the university. They're going to make more money from some biotech stuff or CS or all this stuff, right? Donations, anything. So it's interesting to be at a place where what you do is the coolest thing. It's even at CERN, the theory group compared to the experimentalists, it's not it's clear that that they're valued in the same way. And so you have an institute with all the infrastructure of a university dedicated to your job that's in a good position to try to see that there are some engineering challenges associated with the job that you do, and at least position researchers in a way to kind of be responsible for that, I think is cool.
What is the thing that you're most proud of? I know that you had some great results that were with your supervisor, but also what is something that you're particularly proud of constructing?
So the thing, with my advisors still, but that's fine. So the first paper I had was basically I get credit, but that's his thing. Was the superrotation generalization of the symmetry. So it's finding a new symmetry because Freddie and Andy found a new soft theorem. And so that's great because it was
This is Freddie Cachazo.
Here, in 2014 maybe, had a paper with Andy where they find that there's a new universal subleading soft theorem. And this because Barnett and Trosser thought that there might be another symmetry. And so if you try to say okay, well, say Struminger's realization that the soft theorem is equal to a word identity would work for any other soft theorem, then Freddie's new soft theorem gives you a chance to check for word identity, and that's what we do. So that's something handed, right? But I think appreciating the kind of universality of the memory effects and using that to find spin memory is something I'm super proud of, and it's awesome because there's a way to maybe test it at a future gravitational wave.
So this is pretty cool, right?
Yeah.
So I only know about this because I did some brief reading before this talk, so I don't know much about the effect.
Yeah.
But so from what I understand, and correct me if I'm wrong, as a gravitational wave passes, objects that are sitting in space will move, and then there's a permanency to. They don't just go back to where they were, and you might be able to actually measure this distortion of space-time.
And so that first distortion is from a long time ago, maybe in the 70s or so, Zelovich and Polnareff. But the cool thing is that there's a subleading distortion that also is universal, governed by angular momentum conservation. That was my the thing right before the hyping stuff. That was a cool result. I think it's still cool. I'm happy with that.
No, it's very cool, especially if you can detect it.
I know it was there's something cool that could be related.
I mean, this is a dream, no?
Yeah, it is.
Why did you make the jump into theoretical physics?
Yeah, so I mean, when I was very little, the stuff with aviation was from when I was 9. So I'm 31 now, just. And I don't know. It's super weird, I guess, how these hobbies turn into things. So definitely, someone taking flight lessons at 9, because you don't need to have a pilot's license. You can be with a CFI, so you can fly at any age with a CFI. It's trying to get attention or doing something there. So it was I guess that was the hobby that was kind of offered to me. It was cool. I'm flying, and people would ask "Oh, so one day you're going to be our airline pilot?" And I'm "Oh, no, I didn't want to do that." And then I really admired these private aerospace companies, and so it was the Blue Origins or SpaceX and Virgin Galactic at the time. If anything, was the one I think where Richard Branson was more of a personality at the time, who would Virgin Galactic would show up at like these air shows like Oshkosh, and like these people that I admired, like I was like, how would I try to impress them or whatnot? And so like it was this like path that was a story that I guess we were trying to build of like going from flying airplanes to building an airplane to like working for those companies or whatnot. And so like at 12 or so, I used to go up to these air shows, and like there were a lot of kit planes people were building. And so someone suggested like, you could do that too. And so that was a project that started. And when that was happening, it was a combination of two things. So people would come up and say like, oh, one day you're going to build like the Boeing that we're flying on. I'm like, oh, no, I don't want that. And then, but at the same time, it was also a lot of like networking and whatnot. And I think I went to a high school that was this math and science boarding school. And the person who had founded that high school, he was a previous like director of Fermilab. And somehow like the people I admired in aerospace somehow liked physics on the side. This guy was like, had lunches with a laureate, always talking about physics, bringing in various friends to lecture to high school students. And so it became like the two cool things to me were either be a physicist or like run an aerospace engineering company. And then I guess by the time I went to undergrad, I built this kit plane. It was something where it was like, it's a straightforward thing to do that's cool because a kid did it rather than because it's like intrinsically a cool thing to do. A lot of the excitement at the time in like course 16 was around like playing with drones. So it was more of a CS/robotics venture than like an actual aerospace engineering question. And I did a couple like brief internships, like they were short. And I guess I kind of was the solution. I wanted to do the other option, and I had done well in school, and so I pivoted to physics, I guess, like the first year of undergrad end of it. And the question is like, can we then position ourselves as like a leader in like how research is done to then be a top place, but also learn the lesson of like, do better together than I think that there's issues with hiring in the field, that it's not an issue at like a local level. It's more of like the fact that talent isn't viewed as something that you kind of grow. It's something that you either have or not, or like it's a struggle, and then the people who survive. It's a weird attitude. Like very few people will actually try to help you be better, and that's so weird.
Well, Sabrina.
Yeah.
It's been a pleasure.
Yeah.
Thank you so much for coming on the podcast.
Awesome. Thank you.